Angles of depression and angles of elevation. So when you look at these kinds of questions, first we want to just talk about which one is which. And so I've labeled here angles of elevation and depression so that you can see kind of what they are, but I'll go over it again. So when you look out here and you're in the airplane and you look down, when you look down at something, that's an angle of depression. So this is an angle that goes down from a horizontal. If you want the angle of elevation and you're the person here in the air traffic, tower, and then you look out horizontally here, and you look up at the airplane, that change from you looking out to you then looking up, that's an angle of elevation. And so you can see in the picture over here, I've labeled which angles are which. And you can tell that when you're the airplane and you look out and then you look down, that's an angle of depression. If you were the person and you look out towards the airplane and then you look up at it, that's an angle of elevation. If you're the same person and instead you look down towards that point, that's an angle of depression. And then if you're at the point and you look out and then you decide to look up at the person, that is an angle of elevation. So I'm going to go through a couple examples. The ones on the first page you can try, and the link is in the description. But I'm going to go to the second page because there's a couple right in a row. One is not that bad, and the other one's a little bit tougher. So we're going to look at 6 and 7. So for 6, it says the pilot of the traffic helicopter cites an accident at an angle of depression of 18 degrees. The helicopter's altitude is 1,560 feet. What's the horizontal distance from the helicopter to the accident? So if you're the pilot of a traffic helicopter, so you're in this helicopter-looking thing, little things on the bottom, and you set an accident at an angle of depression of 18 degrees, they must have been looking out this way. And then the accident is somewhere down here. Now, 18 degrees is a pretty small angle, so it's probably going to be out here somewhere. So to make this to scale at least a little bit, I look out at an accident, and so put a sad face for the accident, and they look down at this accident. This angle of depression, since he's looking down, is 18 degrees. So since the altitude is 1,560 feet, I could label this above the ground on this side, or I could label it above the ground on this side. Since my triangle is over here, I'm going to do it on this side. So this is 1,560 feet. So I need to find the horizontal distance from the helicopter to the accident. And even though that distance is on the ground, you can see that this here would be the same as this distance here. So it doesn't matter which way you set it up. They're going to be the same. So this distance here is the same as that one. So using this triangle, I'm going to set up an equation using trigonometry, since that's how you relate angles and sides. So if you look at SOHCAHTOA, now if I'm looking at this angle and I look at the opposite side, I need to make sure I involve that. And then the adjacent side is the one here, so I need to involve the adjacent side. So it looks like we're going to use tangent. So when I set that up, I get the tan of 18 degrees is equal to 1,560 over the adjacent side, which is x. In order to solve this, you have to first multiply both sides by x. This is a step that sometimes people mess up. So you multiply by x, x tan of 15 equals 1,560 feet, and then I divide by tan 15 because that needs to cancel out. So when I divide by that, I get x equals 1,560 divided by tan 15. So that is approximately equal to, let's see, 1,560 divided by tan of 15 degrees. It should be 5,822 when you round it to the nearest foot. If you get something different, make sure to check your mode. You should be in degree mode. So 5,822 feet. So that's how far it is away from the accident. Just over a mile, 5,822 feet. So we'll go on to the next one, which involves this picture over here. The question says that you're standing at the top of this canyon and that the angle of depression to the far side of the river is 58 and the angle of depression to the near side of the river is 74. So if you look at it, the far side is 58, the near side of 74. So you're looking for it gives you the depth of the canyon as well as 191. So it says, what's the width of the river at the bottom of the canyon? Round the length of the nearest meter. So you're looking for the width of this river. So I know that it's a little bit tough to see if you're looking at it in this black and white version, but what you're looking for is this distance, because that's the width of the river. The canyon ends here, and then it goes over to the sand on this side. So there's this amount here, that's how wide it is. So we need to set up some equations to be able to solve this. Now I've got a triangle within another triangle, so it might be helpful to separate them out. Or to relabel some of the other stuff so that you can see exactly what to set up here. So I think it would be easiest to look at this triangle here and then to look at the smaller triangle there. And if I could find the bottom of the large triangle, which maybe I'll call y, and then I can find the length of this small triangle here, which I'll call z, I could take that away and find out what x is. So I can say y minus z is going to equal x. So if you're getting confused by the variables, don't worry, I'm going to set up some triangles to show you how this could work. Let's just make this, there we go. So the first triangle that you could set up here is the smaller triangle. And so this is 191. We know that because that information is given. We also know that this angle here is 74, so that means the angle right here, I should be able to figure that out, and that's 16. That's just 90 minus 74 to get 16. Then I can set up an equation to find out what this side is. I already labeled this z. So I'm going to label my other triangle as well before I solve these out. So my other triangle is a bit wider, and so this I've labeled y. Now, this angle here I have is 58, so I should be able to figure out what this top angle is. That angle, I know this is a right angle, so that angle is going to be 22. Just 90 minus 58 gets me 22. This isn't the only way to set up this problem, but I think it is probably the easiest way. So then I can set up a trig equation involving my two triangles here. So since I have this angle here and I need the opposite in the adjacent side, that's tangent. So the tan of 16 equals the opposite over the adjacent. That means the tan of 22 is going to equal the opposite over the adjacent. Now I can multiply both sides by the denominator here. So since this isn't the denominator, I can multiply both sides by 191. So this equation becomes 191 tan of 16 equals z. If I do the same thing on my other equation, 191 times the tan of 22 equals y. And I can find out what both of those numbers are. I realize I should move this over a little bit so that you can see what I did. So when I go to solve this out on my calculator, 191 tan of 16, and then 191 tan of 22. So it looks like my differences here are 77 and 54. So it says to round to the nearest tenth of a meter. So that means in the middle of the question, I should go to the nearest hundredth. So I've got 71.16 for one of these, which is the longer one. And that's feet. And then I've got 54.77 feet here. So when I subtract those, and I go 77.16 minus 54.76. Actually, that should have been 77. Oh, I didn't round either of these right. So it should have been 17. And this other one should have been 7. Oh, 77 was fine. So when I take those away, I get 22.4 when you round that to the nearest tenth. So you can see that I've got 71.17 minus 54.77. And I end up with 22.4 feet. So that's how far across it is. So you can see that question involved a little bit more, but I was able to still figure it out using two separate triangles and using trigonometry. So if you need to see the work, you can pause it there.